Hi, my name is Jaideep. I am from CSC first year, and today my topic is teaching of Fourier series expansions in undergraduate education. Introduction. Fourier series is a periodic function composed of harmonically related sinusoids combined by a weighted summation. With appropriate weights, one cycle of the summation can be made to approximate an arbitrary function in that interval. As such, the summation is a synthesis of another function. So Fourier series is a periodic function and it is composed of harmonically related sinusoids, which are combined by the weighted summation. So Fourier series is a periodic function and it is composed of harmonically related sinusoids and are combined by weighted summations. With appropriate weights, one cycle of the summation can be made to approximate an arbitrary function in that interval. So with approximate weight, one cycle of the summation can be made to approximate an arbitrary function in that interval. As such, the summation is the synthesis of another function. So the summation is the synthesis of the another function. Next, teaching of the Fourier series expansion. For example, in electrical engineering, there are several instances where one with the signal waveform and manipulation of signals. The manipulation may be any operation such as addition, multiplication, differentiation, integration, etc. This manipulation may be result of tangential electrical circuit, which is RC, LC, RLC, or simply an abstract system. Hence, a strong analytical method is needed to examine the results and side effects. So we have huge application in teaching of the Fourier series expansions. For example, in electrical engineering, there are many instances where a person deals with signals. Signals are waveforms and manipulation of signals. So there is a instance where one deals with the signals and the calculation and manipulation of the signals. The manipulation may be any operation. So manipulation may be of any operation such as addition, multiplication, differentiation, or integration, etc. This manipulation may be result of the tangential electrical circuit. The tangential electrical circuits are RC, LC, and RLC, or simply an abstract system. So the tangential electrical circuit may be of abstract system. Hence, a strong analytical method is needed to examine the result and side effect. So to calculate the manipulation of the abstract system, a strong analytical method is required to examine the results and side effect. So Fourier series are important in the analytical method to examine the results and side effects. Next is motivation. We have topic motivation. Motivation. Fourier series expansions are among the most important studied topics is in undergraduate electrical engineering education. Large fraction of the signal processing and also mathematical literature is devoted to the teaching of Fourier series expansion is of utmost importance, especially when dealing with problems which fall, for example, in the scope of multidimensional signal reconstruction and which includes sampling theory, interpolation, extrapolation, signal and image conditioning, interactive image repairing, deconvolution, and other inverse problems. reconstruction in tomography, filter design, and much more. So Fourier series expansion are among the most imperative study topics in undergraduate electrical engineering education. So Fourier series expansion is the most studied topics in the undergraduate electrical engineering education. Large fraction of the signal processing and also the mathematical literature is devoted to the teaching of Fourier series expansions. So signal processing and also mathematical literature is devoted in the teaching of the Fourier series expansion of the utmost importance. So Fourier series expansion is very important, especially when dealing with the problems which fall. For example, in the scope of the multidimensional signal reconstruction, and which includes sampling theory, interpolation, extrapolation, signal and image conditioning. It is also used in interactive image repairing. Fourier series expansion is also used in deconvolution and other inverse problems. Fourier series expansions are also used in reconstruction in tomography. It is used in filter designs and much more. So for scope is more for the Fourier series expansion in the engineering education. Importance of the Fourier series expansion. Importance. Fourier series in mathematics and infinite series used to solve special types of differential equations. It consists of an infinite sum of sines and cosines, and because it is periodic, that is, its values repeat over fixed interval. It is a useful tool in analyzing periodic functions. So Fourier series expansion is more important in the physics field also. In mathematics, an infinite series used to solve special type of differential equation. So in solving the differential equation, infinite series is used, which are Fourier series. So in differential equation manipulation, the Fourier series plays a major role. It consists of infinite sum of sines and cosines. So the Fourier series consists of infinite sum of sines and cosines, and because it is periodic, so the Fourier series expansion is a periodic expansion. So Fourier series is a periodic, so its values repeat over a fixed interval. It is useful tool in analyzing periodic functions. So Fourier series is a useful tool in analyzing the periodic functions. Next, applications of Fourier series. We have many applications of the Fourier series and the Fourier transformations. Fourier transformation has many applications in physics and engineering, such as analysis of LTI systems, radar, astronomy, signal processing, etc. The Fourier series has many such applications in electrical engineering, vibration analysis, optics, signal processing, image processing, quantum mechanics, econometrics, shell theory, etc. So we have wide range of applications of the Fourier transformation in the field of physics and engineering and electrical engineering. The Fourier transformation has many applications in such as analysis of LTI system. It is also used in application. Its also application is analysis of radar, and it is also applicable in the astronomy. Fourier transformation is also applicable in signal processing, etc. So in the radar detection, the Fourier transformation plays main role. The Fourier series has many such applications in electrical engineering also. So not only in physics, Fourier series have main applications in electrical engineering also, and it plays major role in analysis of vibration and analysis of optics and signal processing. The Fourier series has application in image processing. The Fourier series also has application in quantum mechanics. Fourier series has many applications such as econometrics, shell theory, etc. Fourier series expansions. The number of possible waves are obviously infinite. Trying to change the analytical approach every time we encounter a new signal is extremely impractical. Hence, what we need is a representative signal, that is, a single signal which can capture the essence of almost any signal. This is essentially what the Fourier series offers. It says that any signal can be decomposed into sum of sinusoids. Now, the problem of analyzing the signal reduces to the problem of analyzing sinusoids. So, coming to the Fourier series expansions, the number of possible waveforms are obviously infinite. So, in the calculation of Fourier series, we have infinite waveforms. Trying to change the analytical approach every time we encounter a new signal is extremely impractical. Hence, what we need is a representative signal. So we need a representative signal, which is nothing but a single signal which can capture the essence of almost any signal. So we need a new signal which can detect any signal. This is essentially what the Fourier series offers. So the Fourier series meets with all the requirements needed to capture a essence of almost any signal. It says that any signal can be decomposed into sum of sinusoids. Though, so Fourier series expansion tells us that any signal can be decomposed into sum of sinusoids. Now the problem of analyzing signal reduces to the problem of analyzing sinusoids. So first the problem was to detect the signals by the application of Fourier series expansions. Now the problem is reduced to the problem of analyzing of sinusoids. The disadvantages of Fourier series of expansion. The main drawback of Fourier series expansion is it is only applicable to periodic signals. There are some naturally produced signals such as non-periodic or aperiodic, which we cannot represent using Fourier series. To overcome this shortcoming, Fourier developed a mathematical model to transform signal between time or spatial domain to frequency domain and vice versa, which is called Fourier transform. So not only we have advantages of Fourier series, we also have disadvantages with it. The main drawback of Fourier series is it is only applicable to the periodic signals. But when coming to the aperiodic or non-periodic signals, we can't detect them by using Fourier series, which cannot be represented using Fourier series. So to overcome this problem, Fourier developed a mathematical model to transform signal between time domain to frequency domain and vice versa, which is called as Fourier transform. So Fourier developed a mathematical model which can transform signal between time domain and frequency domain and vice versa. Is called as Fourier transform. Fourier transform is a mathematical model which transforms signal between time domain to frequency domain and vice versa. Teaching of Fourier series expansion. For example, in electrical engineering, there are several instances where one deals with signals, waveforms, and manipulation of signals. The manipulation may be any operation, such as addition, multiplication, differentiation, integration, etc. This manipulation may be a result of tangential electrical circuit. The tangential electrical circuits are RC, LC, RLC, or simply an abstract system. Hence, a strong analytical method is needed to examine the results and side effects. So, coming to the teaching Fourier series expansion, in the electrical engineering, there are several instances where one deals with signals, waveforms, and manipulation of the signals. So, in the manipulation of and calculation of the signals in electrical engineering, there are some instances. So, the manipulation may be any operation. So, the manipulation means the calculation may be of any operation such as addition, differentiation, multiplication, integration. This manipulation may be a result of tangential electrical circuit. So this calculation may be the result of the tangential electrical circuit. The tangential electrical circuits are RC, LC, RLC, or simply an abstract system. So hence strong analytical method is needed to examine the results and side effects. So for the calculation of these operations such as addition, multiplication, differentiation, and integration, we need a strong analytical method to examine the results and side effects. So we have a method which is called as Fourier series expansions, which can solve the operations comfortably. Motivation of the Fourier series expansion. Fourier series expansions are among the most important study topics in undergraduate electrical education. A large fraction of the signal processing and also mathematical literature is devoted to the teaching of Fourier series expansion is of utmost importance, especially when dealing with problems which fall over example in the scope of multidimensional signal reconstruction and which includes sampling theory, interpolation, extrapolation, signal and image conditioning, interactive image repairing, deconvolution, and other inverse problems, reconstruction in tomography, filter designs, and much more. So we have motivation in Fourier series are among the most important studied topics in undergraduate electrical engineering. A large fraction of the signal processing and also mathematical literature is devoted to the teaching of Fourier series expansion is important, especially when dealing with problems which fall. For example, in the scope of multidimensional signals reconstruction and which includes sampling theory. And it is also in interpolation, extrapolation, signal and image conditioning, interactive image repairing, deconvolution, and other inverse problems, reconstruction of tomography, filter, design, and much more. I thank the faculty and the college for giving me this opportunity to speak about the Fourier series expansion. Thank you.